Get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by e-Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Hello there everyone. Assalamualaikum and very good afternoon. Welcome to Pusat Tuisyen Academy Youtuber, a joint venture with e-Didik Malaysia and Kelab Guru Malaysia. #bermula percuma, selamanya percuma. Before we proceed, let's begin our season with the recitation of Kita Al-Fatihah. And for the non-Muslim, please recite your prayer according to your religion. Amin, 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 ya Rabbal Alamin. How is everyone doing today? My prayer that everyone is doing fine and ready to proceed with today's class. I'm Teacher Su from PTE SMK Seri Serdang, Selangor, your moderator for today, and together with me, our control host, Cikgu Hafsah Ayu, Mat Arifin from SMK Sultan Sulaiman, Kuala Terengganu, our observer, Cikgu Nun binti Muhammad Noh from Dielectric Constant Kuala Pilah, Negeri Sembilan, and our important person of the day, our presenter, Madam Rosmaya from SJKC Yuhua Kajang, Selangor. For the record, we are now live on Madam Rosmaya channel. So, as a sign of support to Madam Rosmaya for her hard work in preparing today's lesson, please subscribe her channel, not forgetting ours too. As usual, the lesson will last approximately for 1 hour, and please follow the class up until the end and give your full cooperation in making this season a lively one. Please take note that the certificate link will be given at the end of the season. Besides this, don't forget to claim your credit for today's live class. Collect the credit to redeem the attractive prize in store. The link to claim the credit and the presenter username will also be given at the end of the season. However, please be alert as the 1-letter and 4-digit code to claim your credit will be announced 1 digit at a time during the live class. So, get ready with your pen and paper. I would also like to remind students to use appropriate language and also use appropriate profile picture. If possible, use your own picture. If you wish to post comment on the chat board. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. Okay, students, stay focused, and if you have any question, please write on the chat board, and Madam Rosmaya will try to provide you with the answer. So before we proceed to our lesson, let's teacher announce the first code. The first code is A7. The letter is A and the digit is 7. Okay, so now please welcome Madam Rosmaya.
Okay, hi everyone. See you again today to physics class. Okay, collaboration from Form 6 and Matrix. Teachers all every Sunday 5 p.m. Today. Okay, as usual. Okay, before we start, I just want to announce that the Academy YouTuber, okay, have new features. You can download the apps, the IU apps, Academy YouTuber apps in your handphone. Just go to Google Play Store, okay, search for Academy YouTuber and install. So you can get all the videos, especially for the physics videos from there. Okay. Okay, so I'm going also to introduce, okay, the YouTuber PU teams. Okay, I can see there Chia Ying and Yongjun, okay, is here greeting hi. Okay, so the physics team, okay, we are all teachers here, all teachers here are from physics, PU team, okay, STPM and matriculation teams, I am the leader. We have Teacher Su here, Teacher Ayu, and Teacher Non. And not here with us is Teacher Suhaya. Okay, we also have Maths Pre-U teams in Academy YouTuber led by Teacher Im. And Biology Pre-U, okay, led by Cikgu Faiza. Chemistry Pre-U teams led by Cikgu Shahnon. Perakaunan and Economy led by Madam Fizi, and other subjects like STPM subjects. Okay, we have pengajian MURID, pengajian perniagaan and perakaunan. These are all from STPM subject. Okay, so let's start our discussion today. Okay, the question given already in the link at the description part, and also I post in the already in the chat box the link for the exercise for today. Okay, so we start with the first question. Okay, hopefully you are all ready with the answer. With the answer, if you have done very good, if you have done very good. Okay, let's read the question. Okay, a parallel plate capacitor half filled with plastic is arranged, is charged by a 3.0 volt battery. Okay, as shown below. Okay, so the area of one plate is 100 centimeters squared, and the thickness and the dielectric constant of the plastic layer are 1 millimeter and 3.2 respectively, and determine the energy stored in the capacitor. Okay, the questions one, energy stored in the capacitor. So if you got your answer already, so you can write there in the chat box. Okay, anyone can write there in the chat box if you got the answer already. So what are given in the question here? You are given the voltage, okay, 3.0 volt, and we have area across the area of the capacitor, okay, 100 centimeters squared. So the thickness means it's the separation, okay, separation D, distance between the two plates or separation between the two plates. And lastly is the dielectric constant, 3.2. Symbol used is epsilon. So from A epsilon D here, we can calculate the capacitance, okay. A epsilon A per D. Okay, then the V here, we can use in the energy, okay, the energy stored in the capacitor. So there are three formulas for the energy stored. So which one to be used? Okay, we have three formulas for you. We have half QV, we have half CV squared, and we have half Q squared per C. So which one to be used? It depends on the data or information given in the question. So charge is not given here, Q not given. So the best is the second one, half CV squared. Okay, half CV squared. Okay, so voltage is given 3.0. You can substitute into here. But the problem is the capacitance, because the capacitor here, we have plastic inserted but not fully inserted, only half. So what does this mean? Okay, this means that it is as if we have two capacitance. We have two capacitors arranged in parallel like this. Okay, but the cross-sectional area or the area is divided by half also, because given here the area, where is it? Not mentioned here. Mentioned or not? Mentioned, right? Half inserted half. Cannot see. There, half filled. Half filled. So that's mean the area need to be divided by half. 100 centimeters squared. So half. Okay, in the chat box there, I can see Cikgu Syafiq. Welcome, Cikgu Syafiq, to the physics class. And then, okay, Yongjun, you have your answer already, C. So let's check correct or not. Okay. Now, the capacitance is arranged in the capacitors is arranged in parallel. So we use parallel formula, okay, which is C effective equals to C1 plus C2. Okay, we just add it. It's opposite of the resistance. If resistance arranged in parallel, we use 1 per R formula. But for capacitors, it's opposite. So we can just add the capacitance here. So C1 plus C2, C is epsilon naught A per D. Okay. So we substitute the area become half. So split into 2, 50-50. And then the distance, distance both 1 millimeter convert to meter, meter cube. And lastly is the dielectric constant. One is air, epsilon naught. The other one is epsilon naught, epsilon R. Okay, so substitute the 3.2. So epsilon naught is 8.85 times 10 to the power of negative 12. In your calculator, got this constant. Okay, constant number 32. Okay, you can substitute there. And the answer is 1.859 times 10 to the power of negative 10 farad. Okay, this is effective capacitance, but the question asks for energy. Okay, so you substitute into here. Okay, so your answer is, so Yongjun, correct your answer. The answer is C, 8.37 times 10 to the power of negative 10 joule. Okay, I can see there in the chat box also, Cikgu Faiza. Okay, welcome Cikgu Faiza to physics class. Thank you for joining us. Okay, so the rest of you, if you got the same answer, okay, can write there in the chat box too. Okay, the more the merrier actually, if you write all your answers there together. Okay, so next we go to question 2. Okay, done for question 1. Okay, before that, as a reference, okay, if the dielectric is inserted like this, still half part of the capacitor, but it's on top, top half, okay, top half like this. So if like this, if the dielectric is inserted like this, so this means that the equivalent circuit is the capacitors is arranged in series. Okay, the capacitors is arranged in series. So therefore, you can use effective capacitance formula as 1 per C. Okay, 1 per C effective equals to 1 per C1 plus 1 per C2. So be careful when the questions come up. Okay, like this. Okay, so next question. Okay, so question 2. A solenoid has n turns, length L, and the cross-sectional area A. So the current through the solenoid is reduced uniformly from I0 to 0 in time t. Okay, which expression represents the back EMF produced in the solenoid? Okay, so which one is the answer? So anyone who've done the question can join class here by writing there in the chat box. What's your answer? Okay, so what is given in the question? We have n turns, we have a length L, we have cross-sectional area A, the current change from I0 to 0. So that means the change in current is I0. I0 minus 0 is I0. Time taken is T. So here means di by dt. And then which expression represent the back EMF? So the formula for back EMF, what is the formula for back EMF? This one, this one means we need. This is the what you call that self-induction, self-induction process. So for the self-induction, we can use back EMF. Okay, back EMF formula is negative L di by dt, where L is the self-inductance. Okay, So back MF equals to negative L di by dt. So the MF is induced in the solenoid itself, in the same circuit. Okay, so the back MF produced in the solenoid. So given by negative L di by dt. So di by dt we can get from here. And then the L, okay, L we can get from N, L, and A. Okay, there are three formula for the self-inductance. Okay, the first one Luna, and then from the Luna we can substitute the N here into the equation. So N is number of turns density. Okay, so number of turns per unit length. Okay, so N is number of turns per unit length. So you substitute into here. So you get the first equation and the second equation, and the third equation we substitute into N, the capital letter instead of the small letter. So the capital letter N cross multiply, we get N, L. So you substitute here. So you get the third equation. So there are altogether three equations. So choose the best one, refer to your answer A, B, C, D here. So there's no N, small letter N. Okay, number of turns per length. So that means we use the second equation. Okay, second equation is Luna. Okay, I prefer to memorize this as Luna. Easy to memorize Luna for self-induction. For mutual induction, we use Muna. Muna. Okay, so the answer is no one right there in the chat box. Okay, no one right there in the chat box. So the answer is D. Okay, the answer is D. Okay, so if you got problem, you can ask there in the chat box. Okay, memorize these three equations for the self-inductance. Okay, so now let's go to the next question. Next question. Okay. Okay, question 3. A resistor and a capacitor are connected in series with an alternate current supply. So this is AC, AC alternate current supply. RMS voltage across the resistor and across the capacitor are 10 volts and 7 volts respectively. So what is the potential difference across the resistor and the potential difference across the capacitor? Okay, at the instance, the current in the circuit reaches its peak value. What does this mean? When reach its peak value. So at peak value, so you must know this is RC circuit, RC circuit. So for RC circuit, so you must know the phase difference between I and V. For resistor, I and V are in phase. Okay, for capacitor, I lead V by pi per 2 radian. So I lead V, this one you can memorize as civil in this, use civil equation, civil words, C-I-V-I-L. So for C, I lead V. For civil, V-I-L. For L, inductor, V lead I. Or you can just refer to the shape of the capacitor. The capacitor symbol you use, the capacitor symbol looks like I, right? So that's mean I lead V. For inductor, the symbol looks like EMF, so the V lead I. Okay, very easy to memorize. Okay, so now go back to the question. If I lead V, okay, when the circuit here in series, when we switch on the circuit, okay, at the moment we switch on, the I will become the I peak, the maximum current flow. Okay, after some time it reduce when the charging process for the capacitor occur. Okay, so when I is at its peak, so that's mean the voltage across capacitor is 0. Okay, when the voltage across the capacitor is 0. So we get two answer already here, A, between A and D. So means B, C is wrong already. So now to calculate the potential difference across the resistor. So how? So you can use the relationship between RMS here with the peak value. RMS value and the peak value. So given here is RMS value, so we choose the resistor, because the resistor will give you the V peak here, because we are going to find the potential difference across the resistor. So we choose the resistor which is 10 volts here. Okay, so this 10 volt is the VRMS for the resistor. So you substitute into here and cross multiply to get the V peak, and we get 14 volts. So the answer is A. Okay, so any question? Valamati Ganesan, very good. You get A. Okay. So while I'm explaining here, okay, if you got the idea already, okay, I purposely explain it, give the explanation slowly so that those who haven't done can do it with me together here. Okay, so congratulations, Balamati, you get A answer. Your answer is correct.
Sorry, madam.
Yes.
Sorry for interrupt. Before we proceed to next question, let's me announce the second digit.
Okay, the second digit code.
Okay. Student, please take note. The second digit code for this class is number 1. Number 1. Okay, Madam Rosmaya, can continue.
Okay, so we continue with question 4. Okay, what is question 4? Okay, question 4, let's read first. The questions said that a circuit consisting of a 6.0 volt battery, okay, a 3000 microfarad capacitor, and a 1.0 kilo ohm resistor is shown in the diagram below. Okay, the switch S is closed at terminal P, so the capacitor is fully charged. Okay, so this is charging process when connected, switch on to P. Okay, then it is closed at terminal Q. Okay, then switch off this part, then to Q. Okay, this calculate the time constant for the circuit and estimate the energy dissipated through the resistor after 2 seconds. Okay, so when switch to P, this is charging process. Okay, when the S switch to Q, okay, this is discharging process. So there are 2 processes here. Okay, charging process and discharging process. Okay, must be careful which process is this. Okay, so Youngjun, you got 3 seconds for the first one, time constant. Okay, what about the second one? So the first one, time constant, okay, it's very easy. What is the formula? It's RC. The formula for time constant is R times C. Resistance times the capacitance. So resistance is 1.0 kilo ohm convert to ohm, and the capacitance is 3000 microfarad convert to farad. So you get 3.0 seconds. So Youngjun correct, 3 seconds. Okay, what about the second one? Estimate the energy dissipated. So what is meant by energy dissipated? So the time taken is 2 seconds. So that means the full energy gained by the capacitor here when it is fully charged. So we need to calculate the energy, full energy, okay, when it is in the charging process. And then at the when it is connect to Q, okay, so here energy dissipated through the resistor. So that means this is discharging process. So the energy decrease to certain value after 2 seconds. So what is the energy dissipated? So you can calculate by the UI minus UF. Okay, so UI minus UF. So from the first question just now, I mentioned already the formula for U, right? The formula for energy in the capacitor. So we have 3 formula. Okay, so energy dissipated is initial energy minus final energy. Okay, then the formula just now from equation from question 1, there are 3 formulas. So which one to be choose? So choose the easiest one. So Q is not given, so you can use the second and the third. Okay, it's up to you which one, second or the third. Q is not given, so that means you can calculate Q first. Actually, the second one is the easiest, but it's okay. You can want to choose the third one also can. Okay, the first one also can, actually all can be used. So if you choose the third equation, so become half qi squared per c minus half qf squared per c. Okay, the capacitance is the same. Same. So Q is not the same. Q is not the same. Q is not constant after switch. The switch is open from P then to Q. Okay. So we need to find the total charge first when it is charging. So it's Qi. So for the Qi, we can use Q equals to CV. Okay, you can forget for a while the discharging process, the charging when it is full charge, fully charged. So what is the charge, total of charge? So the C is 300 microfarad. And the voltage here is 6 volt. Fully charged, it will be the potential difference across the capacitor here is 6 volt. Okay, so what is the total charge? We have 1.8 times 10 to the power of negative 2 coulomb. So you can substitute into here. Okay, next is the final charge. When we turn the switch to Q, S to Q. So what happened after 2 seconds? So what is the charge now? So the charge now after 2 seconds will reduce. Okay, will reduce because the charge flow out. Okay, flow out. So the charge in the capacitor will reduce to how many? So we use this equation. This is a discharging equation. Okay, so QF equals to QI E to the power of negative T per RC. Okay, so you substitute the value here, QI just now. After it is fully charged, then connect to Q. So this is QI, the initial charge. So 1.8 times 10 to the power of negative 2. Then E to the power of negative, okay, time taken 2 seconds divided by the time constant, 3 seconds. So you get the final charge is 9.2 times 10 to the power of negative 3 coulomb. Okay, then you substitute into here. Now we have 2 energy, okay, initial and final energy after 2 seconds. Okay, then you calculate, you get 0.054 minus 0.014. So the answer is 4.0 times 10 to the power of negative 2 joule. Okay, any one of you come up with this answer or not? If yes, you can just write there yes. Okay. Okay, let's see if you use another equation. You can use half CV squared also. Half CV squared. It's still okay, and it's the best actually, the best equation to choose because not much calculation to use. So you can use half CVI squared minus half CV squared because the CVI is from the 6 volt. When the capacitor is fully charged, when the switch S to P fully charged, the voltage across the 3000 microfarad here is the same as the source battery supply here, 6 volt. Okay, so the VI we can substitute 6 volt into here. Okay, for the VF here we can use VF equals to VI to E to the power of negative T per RC. Okay, Young Jun got the same answer just now. Okay, 4 times 10 to the power of negative 2 joule. Okay, if you use this equation, okay, you substitute the V6 volt. This is initial voltage. Then it will reduce because the charge flow out when the discharging process occur as switch to Q. Okay, then you get VF 3.0805. So substitute into here, you still get the same answer, 0.054 minus 0.014. There you get same answer, right? It's the faster to get answer for if you use equation 2. You can also use equation 1, but you need to calculate both the Q and V. So more time needed for you. You wasting time lah. Okay, so choose the best equation. Sometimes more than one equation can be used. Okay, next we go to question 5.
Okay, sorry, Madam Rosmaya. Before we
Yes.
proceed to next question, please we shall take a break for the advertisement.
Okay.
Okay, so to student, please stay tuned and continue the class after the advertisement. Okay, see you next time.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay. Welcome back, student, to physics classes. Madam, can you continue next question?
Okay, so we go to question 5 now. Question 5. If you get your answer, you can write there in the chat box. Okay, we have 4 resistors, 2 ohm, 5 ohm, 10 ohm, and 18 ohm. 18 ohm, and then an ammeter. And a very high resistance voltmeter are arranged as shown below. Okay, if 7.0 ampere current, okay, the current here is allowed to flow through the circuit. Okay, calculate the potential difference across RS. Where is RS? Here, RS. And then the potential difference across 10 ohm and 2 ohm. Okay, this one. And the reading of the voltmeter. Okay, this is the voltmeter, and state which terminal of the voltmeter is positive. Okay, so we do the question 1. Potential difference across RS. Okay. So for potential difference across RS, so it involves all the resistors here. Okay, all the resistors. So that means we need to calculate the effective resistance. Okay, effective resistance. Okay, another one, voltmeter here has very high resistance. Very high resistance. So that means no current flow through here. We can assume that no current flow through here. Okay, so before that, Teacher Im there. Okay, thank you, Teacher Im. Okay, come back to the question. So that means there is no current flow through here, so we can find R effective by using 1 per R formula. Because the 10 ohm and 5 ohm here are arranged in parallel with 2 ohm and 18 ohm. So R1 will be 10 plus 5. Okay, and then R2 will be 2 plus 18. Okay, so because these two in series, they are in one line, one wire here. So that's why we add this one. And for these two set of resistors, they are arranged in parallel. So we get R effective. Okay, we can ignore the voltmeter for a while. Okay, you can see clearly how they are arranged in parallel here. So the R effective 8.57 ohm. Okay, so the current pass through both the R to S here is 7. Okay, 7 ampere. Okay, Youngchun 39.1. Okay, let's check. You got same answer or not? Okay, this is the VRS 60 volts. So 39.1 is for which one? 51, yeah. Okay, so the voltage across RS is 60 volts, 60 volts, okay? Because the points start from here and here. So the R effective include all the resistors. Okay, so the VRS done already. It is 60 volt. Next, we calculate the potential difference across 10 ohm and then the 2 ohm. Okay, next question. Okay, next question. Go back to the circuit. We are going to find the VRP. 10 ohm is here to here. RP. Okay. Voltage across RP. So what is the voltage across RP? So we know that the current flow from R to S. Okay. The current flow from R to S. So that means we can use potential divider equation. This is the faster one to get voltage across RP. Okay, so 10 over 10 plus 5 times the 60. Okay, 60 is R to S. So we can use the potential divider. We take a ratio of resistor, 10 per total of resistance. Okay, 10 per 10 plus 5 times 60 volts. So 60 volt from the top one and 60 volt also across the here, the below two resistors here. 60 volt across the 10 and 5 resistors here. Okay, for VRP, the ratio will be 10 per 10 plus 5. Okay, times 60. So you get 40 volt. Okay, 40 volts, V across RP. Okay, Yang Jun. So if you have any question, you can write there in the chat box. You can use also the method in form 4, form 5, secondary, secondary when you are in secondary for 40 volt, V across RP. So we do the same for 2 ohm here. So the ratio will be for VRQ is 2 per 2 plus 18. Okay, 2 per 2 plus 18 times 60. So you will get 6 volt. Okay, RQ, V across RQ. So 6 volt. So that means is here if RP is 40 volts, so total is 60 volts. So the remainder here will be 20 volts. The question just ask for RP, across RP. Be careful. Okay, so if you want to use the method where you've learned in secondary, also can, but you need to find current first, right? So the current 7 ampere split into 2. So for for the current flow R to P to S, okay, RPS, you can use V per R effective. Okay, so the R effective will be 10 plus 5 here. So 60 volt just now from 1. Because these two set of resistor arranged in parallel, right? So the voltage across RS is 60 volt divided by 10 plus 5. So the current is 4 ampere. So the voltage across 10 ohm will be 4 times 10. Okay, 4 times 10, you get same answer, 40 volts. You see, 40 volt. Same answer. So if the current pass RPS is 4 ampere, so that means the current pass through RQS will be 3. Okay, 3 ampere. Because the current here split into 2, right? 7 ampere split to 4 ampere. So 3 ampere will be RQS. So 3 times 2, the resistor here is 2 ohm. So 3 times 2 will be 6 volt. There again, you get same answer if you use this method. Okay, but actually we don't need to find I. We have a shortcut method here. Use potential divider formula. Okay, done for question 2. The answer is 40 volts and 6 volt. Respectively. Okay, not anyone get same answer? Can write there in the chat box. Okay, so we go to question 3. We are going to find the reading of this voltmeter. Okay, the reading of the volt.
Sorry, madam, for interrupt.
Yes.
Before we proceed to next question, let me announce for the third digit. Okay, so the third digit code is number 7. Number 7. Sorry, madam. So, continue.
Okay, so again the number 7, right? Okay, Yang Jun, you said you understand. Okay, good. Okay, now we go to question, third question. We are going to find the voltmeter reading. The voltmeter reading here. Okay, and we are going to determine which terminal of the voltmeter is positive. We have terminal P and terminal Q. So which one is the positive terminal? Okay, so what to do? So the current flow through here. Pass RPS or split another one RQS. So R will be the positive terminal. Okay, S will be the negative terminal, or another word, current flow from high to low voltage. Okay, current flow from high to low voltage. So that means here will be plus 60. Okay, this is potential at R. Remember that potential difference and potential is two different quantity. Okay, potential, or another word, electric potential, and potential difference is two different quantity. Potential difference usually across 2 points, and the potential at R given by BR here at a point. So potential at a point here is 60 volt, and the potential difference across RP calculated already 40 volts. So VRP is 40 volts. So what is the potential at P? So the difference is 40. So that means potential at P is 20 lah. 60 minus 40, so you get 20. Okay, this is potential, electric potential at point P. Okay, so the difference will be potential difference 40 volts. 60 minus 20, so give you VRP 40 volts. Okay, so next we do the same for Q. So we calculate 6 volt just now, potential difference across RQ, so 6 volts. Okay, so that means the potential at Q will be 60 minus 6 is 54 volts. Okay, so VR 60, VQ 54. So potential difference between RQ is 6 volt. Okay, so now we know that electric potential at P and at Q. Okay, one is 54 volt and the other one is 20 volt. So to know which one is the positive terminal, so look at the current flow. Okay, the current flow from high to low voltage, right? So 50 volts is higher. Okay, higher than 20 volts. So that means the reading is 54 minus 20. Okay, it's 34 volts, the reading. And current flow from high to low. So that means the positive terminal will be Q. Okay, terminal Q is positive. Okay or not? Yes, Youngjun there. I just realized your answer there. Q is positive terminal. Okay, because 54 volt is higher than 20 volt and the current flow from high potential to low potential. So the current flow from here to here. So terminal Q is the positive terminal. Okay, Youngjun, congratulations. Okay, done for question 5. Okay, then we go to question 6. If you all got any question, can write there in the chat box. Okay, I can help you if I got anything you not understand. Okay, now we go to question 6. Question 6. A solenoid has 25 turns per centimeter and carries a current of 5 milliampere. So an electron inside the solenoid moves in a circular path with a speed of 1.50 times 10 to the power of 5 meter per second. So determine the magnetic field strength in the solenoid. Okay, determine the magnetic force on the electron. Okay, state the reason why the force does not increase the kinetic energy of the electron, and sketch a vector diagram to show direction of velocity, magnetic field B, and magnetic force F. So we do question 1 first. Magnetic field strength in the solenoid. So you are given 25 turns. So you are given the current I and the speed. So for magnetic field in the solenoid, given by the formula B equals to mu naught Ni bunyi. Okay, that's why given here N, turns per, number of turns per length. Okay, current, then we know mu naught from the your calculator also has this value, a constant value, mu naught, permittivity of permeability of free space, mu naught. Okay, so now B for the solenoid, bunyi. So you substitute the values of mu naught and I, don't forget, convert to SI unit. And your answer is 1.57 times 10 to the power of negative 5 Tesla. Okay, that's the answer. Okay, next for question 2. Determine the magnetic force on the electron. Okay, magnetic force F, F. So you can use QVB. Okay, so Young Jun got 1.11 times 10 to the power of negative 10. Okay, let's check your answer. Don't forget the what you call that unit, the unit, okay. So the unit for force is Newton. So electron is 1.6 times 10 to the power of negative 19. V speed is 1.50 times 10 to the power of 5, and B is 1.57 times 10 to the power of negative 5 Tesla. So the force is 3.77 times 10 to the power of negative 19 Newton. Okay. So the force on the charge inside the solenoid. Imagine the solenoid, and then inside the solenoid there is a charge moving in circular path. So this is the force that act on the charge. Okay, so the force, magnetic force inside the solenoid is constant. Constant. So this with this value. Okay. So the speed of the electron also in a circular path also constant using this speed. Okay, so the displacement of the electron is perpendicular to the centripetal force. So no work is done, and the V also constant, the force constant, everything constant. So the force does not increase the kinetic energy of the electron. The force move in circular. This is the force that provided the circular motion. Okay, centripetal force. This is the centripetal force, QVB, magnetic force that provide the circular motion. Centripetal force in the circular motion of the electron. So that's why no work is done. That means no change in kinetic energy. Does not increase the kinetic energy. Okay, kinetic energy is constant. Okay, not? Okay. Okay, I hope you all understand. Maybe you can just write there, give a sign that you understand. Right there, you understand. Okay, if you got any problem or you make mistake there, and you just write there also. You understand why your answer is not the same as your own answer there. Okay, Youngjun. Okay. Okay, so we go to question 3. Okay, sketch a vector diagram. Okay, to sketch a vector diagram, okay, I help you, okay, teaching. Okay, you said you understand. Okay, I help you all to imagine what it looks like actually when the electron move in circular motion or circular path inside the solenoid. Okay, this is a solenoid. Okay, then electron is inside here, the solenoid. Okay, if you observe, if you use the what you call this grip rule, okay, right hand grip rule. Oh, Youngjun, you put the wrong constant. Okay, so you know where you went wrong, you know where you gone wrong. Okay, very good. Okay, don't make the same mistake again, Okay. Okay, so we go back here. We use the grip rule. Okay, so your thumb, your 4 fingers here shows direction of current. Look at the terminal positive of the battery. So in the solenoid, the current goes upward. So the thumb shows direction of B. So B this way. B this way. Okay, looking from this view, side view of the solenoid. So what you see is this is the solenoid cross section, because you observe through this side, right? So this is a solenoid cross section. Okay, so the B is this way. So into the screen, if you transfer to this this diagram, okay, and from this point of view, so the B is into the screen. Okay. Then the motion of the electron is in circular circular path, circular path. So how you know in this direction? So you use Fleming's left hand rule. Okay, so the B into the screen. Okay, so the force is upward. So the B is into the screen, cross there, and the direction of the motion will be this way, because this is a circular motion of the electron, right? So make sure everything, all FBV is perpendicular to each other like this. So the electron will move like this. Can see or not, you all? So another one. Why the V, your middle finger shows this way? Be careful. This is electron. For electron, okay, so the V will be opposite direction of your thumb. So this way. Look at the green arrow here. So the green arrow here shows direction of the what you call this electron. Okay, opposite, because this is electron. If you use Fleming's left hand rule, your middle finger shows direction of positive charge. So for electron, you make it opposite. Okay, make it opposite. So it's this way. Okay, FB remain the same direction, so the V is opposite. So that's how you label here. Then for the vector diagram, you just transfer to vector diagram. So F is upward, B is into the screen. So the V of the electron is to the left, to the left. Okay, there are many answer actually. If you use the point here, point of electron motion, okay, where it move along this circular path. So the graph, the vector diagram will be like this. You just turn this around. So V is upward, F is to the right, and the B still into the screen. Okay, so many answer. And if you change your point of view, okay, here, this side. Okay, this side. Or another word, in front here, or behind, I think, it's up to you lah, from front view or back view. Okay, so if viewed from here, 3D diagram is also okay. 3D diagram also okay. The questions, okay, can 3D diagram X, Y, Z. You just label with 90 degrees. This is very important. Label the 90 degrees here. If you draw 3D diagram, Yongjun asked there, if I draw 3D vector diagram, is it acceptable? Yes, acceptable. But make sure you draw the, if it's perpendicular, so draw the 90 degrees there, like what I did here. Okay, now go back to this view. If you view from here, you see, so the force will be upward. Okay, so the V is into the screen because you view from here. So the V is into the screen, and the B is the B is to the, what you call this, to the right. If you view from here lah, into the screen, right? So it's to the right. Okay or not? And if you turn this around, also you have another answer. Okay. Okay. So any else question you want to ask? You can write there. 3D vector diagram is allowed, but you must label as X, Y, Z lah. X, Y, Z, or make sure you label with the perpendicular between F, V, and B. Okay. And we go to the next question. Okay. So a solenoid is attached to a battery. Okay. Like this. This is similar to question 6 just now. Okay. But just want to test you. You understand or not question 6? I want to test you whether you understand or not question 6. I think I didn't give this question in the exercise given in the link. So what's your answer? Anyone can try in the chat box there. Write the answer. So a solenoid here is attached to a battery. Then electron is fired into the solenoid through a small hole, okay, in the side of the solenoid as shown here. So which of the following is true about the electron? Okay, so I can see Young Jun again, answer B. Okay, what about the rest of you? What's your answer? Do you agree with Young Jun, B? Anyone? No one? You use Fleming's left-hand rule. Fleming's left-hand rule. So you determine the B first because you need to know B, right? Look at the terminal of the battery, okay, positive. So the current flow. Look at the way the solenoid is drawn. So this will determine the direction of current. So it's upward. Okay, so therefore your thumb shows to B. Okay, now you know the B, so you use Fleming's left-hand rule. So your point finger, your forefinger shows direction of B, and then electron is downward, right? But your Fleming's left-hand rule, your middle finger must show upward, opposite of the direction of electron, because this is electron. Okay, be careful. This is where students always make mistake. So for electron, you use upward direction of the middle finger. And lastly, for the direction of the magnetic force, so it's out of the screen. Okay. So the answer is B, deflected out of the screen. Okay, so correct, Jun, your answer. So those who get the same answer also, congratulations, okay, to you all. Maybe you shy to write there in the chat box. Okay, it's okay. I know that you are all there here with me. Okay, so this is one more question. We still got time, right? So just one more question. It is what you call that? Question. A sudden question from me. Okay, so let's read together the question. This equation also many students forgot. Who knows if come out in the exam? Identify the temperature at which the resistance of copper would be double of its resistance at 0 degrees Celsius. Given temperature coefficient of copper is 3.9 times 10 to the power of negative 3 per degree Celsius. Okay, per degree Celsius. Okay, so what's your answer? Can you remember or not? The formula for temperature coefficient. Okay, many students forgot of this question, this equation. Temperature coefficient. Okay, can you all remember the equation? Formula not given in the exam. Okay, so you should memorize the equation, the formula. Next week is exam time, right? So most school do exam next week for the STPM for STPM SEM 2. Okay, can you remember this formula? Okay, so R equals to R naught bracket 1 plus alpha temperature coefficient and then change in temperature. Okay, change in temperature. Okay, so it comes from the fraction of resistance, okay, directly proportional to the change in temperature. Okay, so it comes from the statement. Okay, so now you substitute what's given here. Okay, double is resistance. Okay, double is resistance, so 2R naught. Okay, 2R naught. Okay, then substitute the temperature coefficient, cancel the R naught. So you rearrange to get T. Okay, Young Jun again there. The answer is B. Okay, memorize this formula. So the answer is 256 degrees Celsius. Okay, so that's all for today. See you next week. We finish the discussion. But it's okay lah, this one. Okay, so we've done until question 8. Okay, I give back today's session to our moderator.
Okay, thank you, Madam Rosmaya. Okay, with God's grace, we have reached the end of today's season. Okay, thank you, Madam Rosmaya, for preparing to the lesson, and congratulations to those who are able to follow our live class from the beginning till the end. Okay, again, students, let's thank Madam Rosmaya by clicking the subscribe button and active the icon bell so that you will not miss the next live class. And also, don't forget to hit the like button. Once you have done that, please type done on the chat box. Okay, so now teacher will announce the last digit code for today's class. Okay, please take note, students. The last digit code for today's class is number 5. Number 5. Okay, give high five and 5. Okay, so, okay, the certificate link and the link to claim the credit are already in the chat box. Okay, the certificate and credit link are given as a token of thank you for your dedication in joining the free online class today, and please share today's live class to your friends on your social media, spread and share the goodness. Please take note, the credit link will end 15 minutes. The certificate link will end half an hour after the live. Make sure to use the eDidik email, MyGuru email, Jawi email, and MOE email only to log in. Incorrect email use will not be entertained. If you wish to get more information on the online classes, go to www.academyyoutuber.com. And those who haven't joined eDidik Junior Telegram, please do so. So once again, I would like to thank all the wonderful students for joining today. Thank you for being an IU supporter. You are awesome. Okay, feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So, don't forget to join our live class next week, Saturday at 5 p.m. Okay, till we meet again, ingat hashtag bermula percuma, selamanya percuma. Stay safe and be safe, student. Assalamualaikum and bye-bye. See you next class.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.